Let's take up just one more, children, and I'll teach you some tips for the Ionic equations, and then we're going to finish, right? I don't want to keep you that long, even. Yeah, I'm tired, so let's take this and see. I think I want to take that same question, that one, but this one, sample of manganese, that we did, right? Okay, now this is also one of the good ones, right? Powdered zinc. I think I missed the previous one. I'll take that too. That's not there. Right, let's take this first then. Here this is first of the Ionic equation again, okay? Ionic equation for zinc, powdered zinc, and aqueous chromium ions. That's it. So if they just give this data, that means this is the iron, this is zinc, right? Only zinc and this one. So you have only two substances. You see here, the products are not given. So now you might think that they are supposed to like memorize everything, right? It's not that you're memorizing everything. It's called deriving, right? You derive it using your knowledge, right? Now you see that your chemistry knowledge is enough to do this, right? So powder zinc is added to aluminium, so chromium. Chromium 3 plus now. You see, there's reactivity series, right? Remember displacement reactions. So in displacement reactions, what we know is always a metal comes, a higher metal can displace. Remember, can displace a lower metal from its solutions, right? From its solutions means from its ionic solutions, right? It might be, they might present as ions there. So here, this is about that. This is a question like that. So this is the half equation. You need to write the half equation of ionic. So they say ionic equation, they don't want the full ionic. It's going to be the full one, right? Because you have the two compounds, the two substances are there. So it will be full actually if you finally write it. If you have to write what happens to zinc and what happens to chromium. Displacement reaction. So if you want to write, there are several ways of attempting this kind of questions. Like you can go like this. A person might say, okay, I like to write the overall equation, teacher. I will write the overall equation and then I come to the ionic equation. Or another person might directly say, I can write the ionic equation now. Straight away, because you know zinc is present. Zinc is present as a metal. Okay, chromium is iron. So now here we have to take. Then we have to have zinc at the reactant side. We have zinc and chromium 3 plus ions. Now the thing is this one of them should reduce and the other one should oxidize, right? It's an ionic compound, ionic equation, and they have not written the spectate ion. So spectate ion is absent here. Still fine, right? This is what we write finally, isn't it? They have asked you to write that without the spectate ion, without worrying about the spectate ion. The zinc atom should be forming the ion, isn't it? Because zinc is now here with this one. The only change that zinc can do is zinc becoming an ion. What does zinc become? Can zinc become negative ions? Some children write nonsense like this. Zinc 2 minus. There are no ions like that exist in the nature. Zinc doesn't like to form negative ions, right? Zinc likes to form positive ions because it's a metal. For chromium too, if it either forms a positive ion or it stays as an element, right? So here zinc 2 plus is the ion that you get. Zinc forms the 2 plus ion. It likes to form the 2 plus ion, oxidizes, right? Oxidizes. Then chromium 3 plus will reduce, yes. Chromium will reduce to its metal atoms. Yeah, chromium atoms will be there. Now they're giving 2 marks. Can you see here? In this question, they're giving marks, 2 marks. Here, in that case, we'll be careful, right? Check whether the equation is balanced. The problem is many people will write this equation. The next level needs the balancing. It's next level, yeah. Next level balancing is here, right? Isn't it? Interesting kind of balancing is there, children. You see here, there's plus 3 and this is plus 2. How can you make this equal? Now, you know, in an ionic equation, full ionic equation, you can't put electrons on one side. These are not half equations. The half equations, the two half equations have combined also. So this is the final ionic equation. Can we have electrons on one side? No, right? Can you put electrons on either side? In that case, electrons should be equal in number. Then it won't do any difference here. You can't get that, right? You can't put electrons here. So that means we have to multiply this number somehow and get this charges problem solved, right? Here there's 3 plus charges on the chromium atom. On the right side, there's zinc 2 plus ions, right? Now, 3 plus and 2 plus on the right, on the left side, on the reactants, the total reactants have this only 3 plus here, right? The total products have only 1, 2 plus here. What shall we do? Make them balance, equal to, make it a, you can only make them equal to a highest common multiple, right? We call it highest common multiple of 3 and 2 is 6. You can try to make it a 3, you can try to make this 3 a 6 and this 2 a 6 as well. Then it will be balanced on either side. The equation will be balanced, right? So 3 plus, to make a 6, you need to put 2 in front of this, isn't it? Chromium atom should be multiplied by 2. Or chromium ions should be multiplied by 2. Therefore, our chromium atoms should be multiplied by 2 as well. Right? Otherwise, the atoms will not be balanced. Now, don't put charges there, okay? Don't be crazy. Then zinc 2 plus here should be also multiplied by a number to make it 6, right? So, multiplied by 6, 3 here. So, zinc 3 plus 3 into 2, 2 plus ions. Zinc 2 plus ions into 3. It's going to be 6, right? 6 plus. Now here our 6 pluses and this 6 pluses, reactants and products 6 pluses are cancelled. The charges will be fine. But our zinc atoms will be cancelled with this side as well. What is zinc atoms here? There are zinc, sorry, on this side zinc atoms only 1 is there. And on this side zinc ions we have 3 ions. That's how we read it. Don't say 3 into 2 ions. It's not the ions. This is just 3 zinc ions. Okay. So 3 zinc ions should be balanced by multiplying the zinc atoms by 3. So you get 3 zinc atoms becoming 3 zinc 2 plus ions, while 2 chromium 3 plus ions becoming 2 chromium atoms. This happens because of the transfer of electrons. Yeah, this is the displacement reaction. Yes, right. You have to identify the 2 substances there. That's it. What does it become? The thing is this, you know zinc is there, you know this one is there. So you know it one has to be oxidizing, the other one has to be reducing. This oxidizes and this reduced. Right? This oxidizing now, and this is reducing. Right? Okay, now identifying that for the paper. Okay, that was the another ionic equation. Right? You have some ionic equations like that. Different types of ionic equations are there. Okay, I think somewhere here we have a question that I want to talk about. This is not that one. Can't I get it? It is that, right? This one. So, because is the last one I'm taking from the ionic equations. Please do this, and then we'll talk about the tips. Okay, right. Aqueous copper sulfate reacts with aqueous potassium iodide. You must have come across ones like this as well, isn't it? You have come across this as well, right? Copper sulfate and potassium iodide. Potassium iodide, they have not even given the symbol O. Here also we have another symbol. You can write it down. Copper sulfate. Symbols are important. Potassium iodide. Right? And then the ionic equation for this reaction is given. Copper 2 plus potassium, sorry, iodide. They're giving the iodide, sorry, they are given the ionic equation already. Okay, copper iodide and iodine because it's a solid forming reaction. See, this is a solid form newly, so anode equals also form. But there are two things forming, and this is the ones that combined here. That's because of that's now this is usually you're not supposed to memorize this kind of reactions because of that they have given it, right? If you're not supposed to learn it in your syllabus to memorize it, they give that equation. And still they have given that and ask you the question. Question was why or how this equation becomes oxidation? Why does this involve oxidation? Who has oxidized actually? You need to identify that first. Copper 2 plus ions have become here copper. What has it become? The 2 plus ions, you have to be careful here. It's a bit of a tricky part here. Copper and iodide is there. What's the ionic number of copper? You think always 2 plus? You should remember there's a thing, it's a transition metal. Copper is a transition metal, but there are some transition metals that do not have variable oxidation numbers like silver, zinc, like that, right? But copper is a transition metal that has variable oxidation numbers. So what's the variable oxidation number here actually? This one is 2 plus. Here what's oxidation number? First break it down. Copper and oxygen, iodide is there. So take the ion here. Iodide is always, iodide is a -1 ion. Iodide is a -1 ion. Right, that means copper is copper in this case is plus one ion, right? This copper is +1. Don't worry about this balance number. The number that you use to balance is not involved with the oxidation numbers, right? So here we have the +1 copper. So copper +2 has become +1 here. It is reduced actually, right? It is not oxidation. So they're asking for oxidation. Which one is oxidized? Iodide. Iodide is -1. Look at this -1. And it becomes 0 here. Minus to 0 is oxidation, right? So you can write that. What's the statement? Iodide ions, what is reduction to an oil rig? Oil or rig? Rig, right? You need rig, no? Yes, yeah, okay. This is a oxidation, sorry, this is oxidation, so oil actually. Oxidation means loss of electrons. Look at this iodide. Iodide ions, iodide minus ions, iodide minus ions, lose, oh, ion, bit of 1, okay? Ion loses 1 electron, or you can take it as plural, right? 2 iodide ions. You can write like that because you're going to make iodine molecule. 2 iodide ions sorry, in that case, English, right? 2 iodide ions lose how many electrons? 2 electrons to form what? Iodine. We need to make the molecule, remember the story? Right? 2 iodide ions lose 2 electrons to become iodine molecule. Remember that iodine lost the iodide ions, 1 minus charge is lost and become 1 iodine atom. And then it can combine with another iodine atom to make iodine molecule, right? Okay. Yeah, we discussed many ionic equations. Let's see whether there's one more. But I'm going to go to this was also there. Hydrogen fuel cell, and then they ask you to write sometimes half equations like this. I think I'm taking some like half equations. So here hydrogen gas is there, right? And there's lots of electrons as well. So whatever it is, children, if hydrogen gas is on the other side, one side, and there are 2 electrons on this side, that means there should be the ion on the other side, isn't it? There should be a charged particle because it is 0. Like that also you can think. You can think it like that as well. You see? 2 electrons are lost. So this is an oxidation or reduction? It's an oxidation. So 0 should be oxidized. And you know, hydrogen's oxidized state, only oxidized state is +1, right? Can hydrogen go for many other oxidation numbers? No. It can only have +1 state, right? Other than 0, it has only +1 state. So we have to write it plus here. And because there are 2 hydrogen atoms involved in the molecule, right? In the molecule, we have 2 hydrogen atoms. So this should make 2 hydrogen ions, right? Because there's 2 atoms to make 2 ions by losing 2 electrons. That's it. Right, this one, oxygen and 4 hydrogen and 4 electrons. Let's see what happens here. Oxygen 2, that means oxygen 1 molecule, and 4 hydrogen ions. That means you're getting only 1 compound. What is the 1 compound that can form from this combination with some addition of electrons as well? With the addition of electrons and these two combined to form water. Only water, right? That's it. Huh? So is it how many water molecules here? It should be 2 water molecules. Now sometimes some are careless. Just like water, the ion go away. In this case, because you have 4 hydrogen ions and 1 oxygen molecule completely, it should be 2 water molecules, isn't it? Right. Just don't be careless, that's it. We did that. Oh, this one. The same question previous one. Chromium is extracted by the reaction of aluminium. Aluminium is just aluminium, Al, and chromium oxide they have already given. Right? Chromium is extracted. What's the meaning of extracted? Extracted means displaced, right? Isolated or reduced. You can tell in other words, we have reduced this dye or we have isolated this one from chromium oxide. That means chromium has been taken from chromium oxide, right? Using aluminium. So what should be the reaction? Now the point is, some of you have problems in understanding. That's the case. So these two are the reactants. In this case, you identify that this is one product. This is one product. You might have another, if you have another product, you have to decide that as well. Okay. So the first you write the reactants. And not ionic equation even. They are asking for normal equation here, right? So aluminium plus chromium oxide gives chromium plus what should be the other compound? This is like a thermite reaction, right? What you get? You should get aluminium oxide because there's oxygen on the other side. So where should aluminium oxygen go? Oxide, right? The point is aluminium oxide, you have to write the correct formula. You have to do the crystal somewhere and take it here, right? This first with aluminium 3 plus and oxygen 2 minus oxide 2 minus ion. You get Al2O3 switching like this. Okay. 1 mark. So, oh, forgot. The reaction should be balanced here. I was not talking about it. Also, chromium, not chromium, which have is aluminium. This is an extraction reaction, isn't it? Balance this. You can put the number of aluminium and oxygen is balanced already. Oxygen 3, oxygen 3. You see aluminium is not balanced. Put 2 in front of this. And you see chromium is not balanced. Put 2 in front of this. That's it, right? Balance. Even you can add state symbols also. These are all actually solid stuff. Okay. Now some tips. I told you that there are some tips in the case of ionic equations, right? Half equations also. Half equations also we have to write, right? We did, I think, a few half equations only. We didn't come across many half equations here. Right. Can I tell tips for you? A few tips for some substances, right? Some reactions we can even directly study the equation, right? Like acid-base reactions, remember? I told you acid and alkali reactions, right?
Hydrogen,
Yeah, if you have acid
hydrogen
and
and salt.
alkali, yes, acid and it should be alkali, okay? Alkali reactions, you know what's happening? You get the salt and water, right? This reaction, there, what happens is you need to write like there's always any acid. What do any acids contain? There is a particular ion that any acids contain, right? That's hydrogen ions. And any alkali contains another. Alkali means a soluble base, right? So any alkali contains this ion, hydroxide ion. You get a salt, but that doesn't matter because the salt is going to be containing the ions that are spectate ions. So we don't need to write that because that is coming from the part of acid and part of base, right? Part of the alkali. So you get a salt which is not useful in the ionic equation. This is ionic equation we are writing. Okay. So in this ionic equation, we can directly say H plus and OH minus is water. This is the equation for any acid and alkali, right? Alkali, it should be alkali, but alkali means the hydroxide, you know, soluble hydroxides, okay? Take an example and see if you want. HCl, most common one, HCl plus sodium hydroxide give you sodium chloride, you know, the salt, right? And water. The point is this now, here break down the ions. You see, HCl means H plus ion, right? H plus ions and chloride means minus 1 ion. Sodium is a plus 1 ion. OH is a minus 1 ion, right? Again here sodium is a plus 1 ion. Chloride is a minus 1 ion. And this is water. We can't break it down because it's water, the liquid, right? So what are the ions that are spectators? The ions that are not involved in the reaction. If you break down and cancel them, you can see that chlorides are going to be cancelled because they are present on either side. Chloride minus, chloride minus. Chloride in hydrochloric acid, that means from the acid, the anion, and the salt contains, that's it. Acids and ion is there in the salt, right? And here you can see the basis metal ion, the basis or the alkalis metal ion is present in the salt as well. Sodium plus, sodium plus. Can you see that? This sodium plus is as it is here. So we can cancel them, they are spectators, right? Spectate ions are getting cancelled. So finally you are left with the ions that you're talking about here. See, this is hydrogen ion, right? And this is OH minus ion, okay? And this is water, right? That's the remaining stuff. We get hydrogen ions and OH minus ions to make water, right? That was the ionic equation for any acid, children. Even if you write it for ethanoic acid or methanoic acid or any organic acid with any kind of an alkali that contains an OH group, okay? There should be OH group in the alkali. That means it should be a base which contains a hydroxide ions, okay? And then the reaction is going to be, ionic equation is going to be this. You can write the state symbols. This is aqueous because it's coming from the acid. This is also aqueous, it's coming from the acid. And our water is a liquid. Water is a liquid, that means a covalent substance. So we need to write it as a separate compound. It's a compound, separate compound, right? Water. So water making is what happens in the neutralization reactions in the ionic equations of acid and alkali, right? Now I'm going to take another one. Okay. I'll show you another one with bases. What about that, children? With an oxide. What happens if you use acids and oxides? This time let's take a metal oxide. Metal oxide, acid and metal oxide. Still you get the same result, now salt and water. Again, you can see the point, right? Salt is not going to be there in our final ionic equation because this salt is in this reaction, okay? This salt is containing the ions coming from acid and the base, right? Metal oxides are bases. Remember that? Now let's write the example then. Here also what happens is acid ion is there. Acids contain hydrogen ions. Any metal oxide contain oxide ions, right? And they are going to form as water. That's the new reaction. That's the new thing form, right? And here we have to put, the problem is we have to balance this. We need 2 hydrogen ions. You will see that the reaction, whenever reaction happens, the acid has to be containing 2 hydrogen ions to combine with 1 oxide ion to make water molecule. So 2 hydrogen, because this is 2 hydrogen atoms, right? Or else you can write in other ways. You can just check it in an equation as well. Let's check it in a example. Like I'll take different one this time. You can even take sulfuric acid. So you have to use hydrochloric acid now. So let's take sulfuric acid here and metal oxide like I'll take sodium oxide. Why do I say magnesium? Magnesium is easy. In this case, I mean, I'm going to write this with this. This is magnesium oxide. Oh, sorry. Magnesium, right? Sodium oxide. Okay. Now what do you get? You're getting a salt. What's the salt you get? Sulfuric acid and sodium oxide. What will be the salt? Sodium sulfate. Let's write sodium sulfate. Colors. Sodium sulfate. You write the crisscross somewhere, okay? You can see it's like sodium sulfate. You write like this, Na2SO4, because SO4 is a 2 minus ion, right? Right now, Na2SO4, and you can put water here as well. And first balance the equation and see, right? This is the equation balance. Yes, H2 sulfuric acid, right? So in H2 here, sulfate here, Na2 here, oxygen here, right? That way also you can check. Yes, this one is balanced, right? This equation is balanced because this is one oxide and there's sulfuric acid that contains 2 hydrogen ions, right? Here there are 2 hydrogen ions, that's why. Right, let's see the cancelling of the ions. We have to break down the ions. We have to break down the ions here. Break down the ions. Can write the charges. This is H plus ions. There are 2 of them. 2 ions are there actually, 2 hydrogen plus ions. It's a hydrogen plus 1 ion times 2. Okay. Right. The sulfate ion is minus 2 ion. Sodium ion is plus 1 ion. Right. There are 2 of them. Fine. That doesn't matter. This is the charge. This is the oxidation number. Oxide is a minus 1, 2 ion. Right. And then again sodium is a plus 1 ion. There are 2 of them. That's okay. And sulfate is a minus 2 ion. Okay. And water you can't break down. You see, sulfate ions get cancelled with the sulfate ions. And sodium ions also get cancelled with sodium ions. There are 2 sodium ions here, 2 sodium ions here as well. So get cancelled and you are left with 2 H pluses. Here this 2 means there are 2 hydrogen ions, right? The meaning is 2 hydrogen ions, right? 2 hydrogen ions and 1 oxide ion makes water molecule, right? Right? Okay. That means for any metal oxide with acids, with any acid, you can take any acid. Okay. The result will be for Ionic equation. The result will be always this. Even if they give methanoic acid or ethanoic acid or anything, the result will be H plus ions, 2 H plus ions combined with oxide or 2 minuses, 2 minus oxide 1 ion, form water. If you write the state symbol here, hydrogen ion is aqueous, always coming from acid. So our acid solids or aqueous. They are mostly aqueous unless you specify as solids, right? This is a solid substance. It's an oxide. Metal oxides are solids at room temperature. What is a liquid? Right, that's it. Okay. Then the next one is just metal carbonates. Also, you can write like this for the reaction that involves carbon dioxide as well. Wait a minute. And write the half equation, any half equation for other stuff. That's just being careful, right? If you have a problem of writing it, just break down the compounds. That's it, and find the expected ions and cancel them. If you take carbonate, student, most of the times metal carbonates are insoluble, right? They are also solid. So you can start like this with acids. They are going to be hydrogen ions, and carbonate means they contain carbonate group. Let's try the carbonate group. Carbonate group is CO3, 2 minus, and you get what? Here also you get a salt. That salt is not useful here in the ionic equation. What finally happens is you get carbon dioxide and water. To balance this, you need, I think, 2 hydrogen ions. That's it, right? You can write this with an equation, some example like this. Let's take nitric acid if you want, because it should try with different acids, right? Nitric acid, and let's take calcium carbonate. What do you get? Carbon dioxide plus calcium chloride, first chloride, calcium nitrate. I was thinking of giving chloric acid as well. Calcium nitrate plus carbon dioxide plus water, right? These are the products. Those are the products now, right? Let's break down the ions. Nitric acid, calcium carbonate. You can break down the ions and see, right? Here you can see this is actually this one, right? We need to have 2 nitric acids anyways, right? Look at this nitrate. Yeah, in calcium nitrate we have 2 nitrates now. So our nitric acid should have been multiplied by 2, right? Otherwise you can't balance this equation. This is not balanced. So now you get 2 2 ions. Can you see that 2 hydrogen ions are there, right? 2 hydrogen ions, and nitrate is a -1 charge, right? Calcium is a +2 ion. Carbonate is a -2 ion. Sort out like that. And again, calcium is a +2 ion because it is second group, right? Nitrate, you should know that from the polyatomic groups. Nitrate is a -1 ion. Yes, 1 minus ion, it is multiplied by 2 here. That's why it is cancelled here, right? When calcium is combining with nitrate, we have to take 2 of them. Remember, these are just the ions, right? We broke down the ions now, and you can see there are 2 nitrate ions here. This is also multiplied by this, huh? We have 2 nitrate ions. You can cancel these nitrate ions with these nitrate ions, right? And calcium ions get cancelled with calcium ions from the base get cancelled with the calcium in the salt. Now finally you're left with what? 2 hydrogen ions here. Look at this, right? 2 hydrogen ions, carbonate ion, right? And carbon dioxide, water. Can put the state symbols also here. This is also aqueous, right? Hydrogen ions are coming from acid, so it's aqueous. Carbonates mostly are solids, okay? You can take aqueous too in the case of first group, sodium, potassium, ammonium. You can take them as soluble carbonates. You can refer to solubility table for that. And then carbon dioxide is a gas, water is a liquid. Equation is balanced with 2 hydrogen ions, right? Be careful with this one because hydrogen should be balanced in the case of water. First write the equation and always check for the balance, right? Whether it's balanced or not. Okay, that's for the metal carbonates and acids always, right? This is the common ionic equation for metal carbonates with acids, right? Likewise, we had 3 sets: metals with metals, not metals, metal hydroxides with acids, metal oxides with acids, and now metal carbonates with acids. So then children, we're going to stop. Okay. Okay.